Hello students, in this video we're going to talk about isomers. First, we're going to look at the definition of isomer. What is isomer? Isomers, they are compounds which have the same molecular formula but a different arrangement of atoms, or we call it as structural formula. So this question is usually asked in paper 4. Make sure that you provide the keyword of the same molecular formula but different arrangement of atoms or different structural formula in order for you to get full mark, which is 2 marks. Now we're going to look at few examples. The first example is that we need to draw and name all the isomers for C4H10. So when we are asked to do this type of question, what we need to do first is that we need to draw the structural formula for C4H10, which is a butane. Okay, and then from here we will be trying to draw another isomer for butane. What we're going to do is that we're going to numerate the carbon. For example, I'm going to numerate the carbon 1 from the left to the right, so 1, 2, 3, 4, and then I'm going to take a portion of the carbon, for example CH3 from the carbon 4, and then I'm going to try to rearrange the arrangement of the CH3 from in this molecule. So if you were to look here, the C4 is currently attached to carbon number 3, which means you cannot exchange the position of this C4H3 with this hydrogen and the hydrogen on carbon 3 for this both hydrogen. Okay, and so what you need to do is that you might try to arrange the C4H3 with the C1. But then if you were to do that, you will get the same thing, butane. All right, for example, you want to exchange C4H3 with this hydrogen, you will see that you will still get the straight chain of butane, which means number 3 you're not allowed to attach with C3, you cannot attach with C1. So the solution is that you're going to exchange the C4H3 with this hydrogen, not with this one. Okay, or you can take this as well, either from these two. Okay, and in this example you can see that here I already attached the C4 to this hydrogen, which means that here I'm going to get 2-methylpropane. How do we name this isomer? So the rule is that you need to numerate the longest carbon chain. In this case, I will get 1, 2, 3. It will be propane. Okay, why is it not a butane? Because you cannot possibly numerate 1, 2, 3 and then you put it 4 here, because it is not continuous. You don't say that, you don't numerate it 1, 2, 3, 4 like this. It must be like attached, the carbon must be attached to each other. All right, so that now that you have the propane, you just need to write down the name propane, and then if you see here, you have the substituent of methyl, which is the CH3. Okay, so it does resemble to CH4, which is methane. That's why the name of this substituent, we call it as methyl. And if we were to name the isomer, it will be 2-methylpropane, because the substituent methyl is currently attached to carbon number 2. Now we're going to look at the second example. Here we have C4H8, which is a butene. All right, so how do we draw the isomers for butene? The first thing that you need to draw is butene, which is the one where you put the double bond on the left or the right side, far end of the right side of the molecule. So this one, it will be considered as but1 in. Why is it but 1 in? Because if you see here, you have the double bond, and this double bond is attached to this carbon, so we're going to name this carbon as number 1 and this is number 2. All right, so this is your isomer number 1. How do you get to the isomer number 2? For alkene, you have the double bond as its functional group. So what you can do is that you can just rearrange the double bond so that you can have another isomer. For example, you can transfer this double bond here in the middle, okay, so that if you transfer it here in the middle, you can numerate it. For example, from the right side, you can have 1, 2, 3, 4, and if you see here, the double bond currently starts from carbon number 2, so the name will be but2in. You might be thinking why you cannot put the double bond here. Why you cannot put it here? Because if you were to put it in this position, you will see that you will have to numerate the carbon back from here, left to right, because the double bond will start here, which means you will still get but 1 in. Okay, so the only solution with the double bond is that you need to transfer it in the middle of the molecule, and you will get your but2 in. All right. Okay, next, the third isomer that you can get is this one. How do we get this? So the concept is the same. I will start from this but1 in, and then I'm going to just take a portion of the CH3 here. Okay, so we know that this is 1, 2, 3, and 4. I'm going to take the C4H3, and then I'm going to attach it anywhere in this molecule. For example, here it is already attached to carbon number 3. So we can't possibly attach it to carbon number 3. You cannot change it with this hydrogen or this hydrogen. So it's not possible. What you can do, for example, you can exchange with this hydrogen, which is on the carbon number 2. So this is what you have after you rearrange the atoms or the methyl. And this is the hydrogen that you exchange it with, and the methyl that you exchange with the hydrogen. Okay, so you have this isomer. Now you need to name it. How do you name it? As usual, you numerate the longest carbon chain. We start from here because the double bond starts with this carbon. So you have 1, 2, and 3, which means you have prop 1 in. And then you have the substituent methyl also at the carbon number 2, which means you will have 2 methyl prop 1 in. All right, so this is your these are the 3 isomers for your butene. Now we're going to look at another example, which is if you see here, we have the propanol, because we have C3H7OH, so this is a propanol. All right, so if you have a functional group like propanol or alkene, it will be easier actually for you to draw the isomers. Okay, so the first step, as usual, you just need to draw the propanol. Okay, so this is your first isomer. We can actually precise the name of the isomer as propane 1-ol because this carbon is currently attached to its functional group OH, which means you need to numerate this carbon as 1. Then here we have 2 and 3. So this is your propane 1-ol. For the second one, as what we did with the butene just now, what you need to do is that you need to rearrange the functional group to the other carbons. Okay, you cannot attach it to carbon number 1 because it's currently, if you see in the propane 1-ol, it's already attached with the OH, and you cannot attach it to the carbon number 3 as well, because if you were, for example, to exchange position with this hydrogen, you will see that the numeration, if you were to put it is hit here OH, you will see the numeration will change 1, 2, and 3. You need to numerate it left to right, and you will still get propane 1-ol. All right. So in this case, the only option that you can do is that you can exchange the OH with this hydrogen, for example, on which is attached to carbon number 2, and you will get your another isomer. In this case, we call it as propane 2-ol because the OH is currently attached to carbon number 2. So this is your 2 isomers for propanol. We shall look at another example, which is pentane, C5H12. Okay, so this is your pentane, and then we're going to try to draw the 3 isomers for pentane. So the first isomer, as usual, you can draw the straight chain of pentane. You can show all of its atoms, carbon and hydrogen, and the bonds as usual. Okay, so this is your pentane, and then what you can do is that, as usual, you're going to take one portion of the molecule. For example, you can take from here. I'm going to just numerate it from the right side. So here you have 1, 2, 3, 4, and 5, which means I'm going to take the C5H12. Alright, so if you see this one, it's already attached to carbon number 4, so you cannot exchange with any hydrogen that is attached to carbon number 4, and you cannot also attach it to the carbon number 1, because if you were to do that, you will still get pentane with a straight chain. Alright, so here what you can do is, for example, you can attach to carbon number 2 or carbon number 3. In this example that I show you, so the CH3, C5H3 is currently attached to carbon number 2. Okay, and then for the third one, as usual, you need to take a portion of the, for example, you can take C4H3, and if you see this one, it's already attached to carbon number 3, so you cannot do that, and you cannot also attach it to carbon number 1 because you will still get the same isomer with the isomer number 2, which means your only option is to attach it to carbon number 2, and you will get your third isomer. Alright, so the first isomer, you name it as pentane, so this one is easy. The second one, as usual, you need to numerate the carbon, the longest carbon chain. In this case, you have 4 longest carbon chain, which means it will be a butane. And then if you see here, you have the methyl attached to carbon number 2, so the name will be 2-methyl butane. And then for the third one, as usual, you numerate the longest carbon chain. I'll just take the middle one, so you have 1, 2, and 3, which means here you will have propane, and then if you see here, you have 2-methyl attached on carbon number 2, which means the name will be 2,2-dimethylpropane. Alright, so why do you need to put 2,2 and di? Because if you see, you have 2 methyl currently attached to the carbon number 2. Now we shall look at how we can name the isomers. So the rules is that you need to put the prefix. Okay, so the prefix will be the position on which you can find the substituent, and then the parent is actually the longest carbon chain, and the suffix is actually the functional group. All right. Okay, so how do we name the isomers? First thing first is that you need to select the longest carbon chain, and then you need to name the branch chain attached to the parent chain. You need to identify the position of the alkyl group that is attached to the parent chain by number. So this is when we have already enumerated the carbon chain, main carbon chain. And then you need to identify if there are more than one similar branch. So in this case, we need to use the prefixes such as di, tri, and tetra. Okay, so we shall take one example. For example, you have this molecule, this isomer, So you do as usual. What you need to do is you need to select the longest carbon chain. So here I'm going to just do it. Here in the middle I have 1, 2, and 3. And then I need to name the branch chain attached to the parent chain. So the branch chain is this one, which is methyl. And then I need to identify the position. The position is currently at carbon number 2. So the name will be, if you see the parent chain, you have 3 carbons, so it will be propane. Okay, that is your parent or the main chain name. And then you need to put the position of your substituent, which is methyl, 2-methyl propane. Okay, so 2 will be, it will tell you the position on which the methyl is attached to. And then propane will tell you how many carbon in your parent chain. Okay, so this is your first isomer. The name will be 2-methyl propane. Alright, so the next example, you have this isomer. As usual, you're going to select the longest carbon chain. I'm just going to take this one, 1, 2, and 3. Okay, if you see it is a continuous numeration 1, 2, 3, you cannot possibly put 1, 2, 3 and then here 4 and then this one 5. Okay, so that is not allowed. Alright, so now that you have your longest carbon chain, you need to identify the branch chain. For example, here you have 2-methyl currently attached to carbon number 2. So if you see here the parent chain, you have 3 carbon, right? So it will be a propane, and then you have 2-methyl, which means it will be dimethyl, and the position on which these two dimethyl are currently attached to, they are attached to carbon number 2, which means you need to put the name as 2,2-dimethyl propane. Okay, so the next example, we have an alkene. Alright, so as usual, you need to select the longest carbon chain. I'm going to just numerate it from right to left. So I have 1, 2, 3, 4. And then I'm going to select the position of double bond by choosing the smallest number for the carbon atom with CC bond. So here the smallest number is actually 2. And then I need to identify any position of the alkyl group, but here in this case we don't have any alkyl group, which means if we were to name it, we need to name it as but2-ene. Okay, so for alkene, the position of the double bond is actually, you need to put it in the middle of the name. Okay, so it is different from the alkane that we have seen just now. Alright, so on to the next example, we have also an alkene. As usual, you need to select the longest carbon chain. So if you see here the second one, it says that you need to select the position of double bond by choosing the smallest number for the carbon atom with C double bond C. What does it mean? So the longest carbon chain is actually, I would say 1. So 1, 2, 3, and 4, or you can go up like 1, 2, 3, and 4. So it's up to you. For me, it's easier if I just do it like in a straight line so that we can see it like clearly. What does it mean by number 2? Is that you need to numerate the carbon that has the double bond you need to start the numeration starting from the carbon that has the double bond, because you want the numeration, the naming on which you want to put the position of the double bond, it must be the smallest number ever. So you cannot possibly like put this as 1, 2, 3, 4, because if you put it, it will not be but1-ene, but instead it will become but3-ene. Okay, we don't want 3 because this is higher than 1, so we will stick with this one. Okay, all right, so which means that if we were to follow the rules, we need to numerate 1, 2, 3, 4 from the left to the right in order for us to get but 1 in. Okay, and then we need to identify the position of the alkyl group, which is here. We have the methyl, and it is currently attached to carbon number 3, which means the name for this molecule will be but 1 in, and then we have the methyl currently attached to carbon number 3, so we're going to just name it as 3-methylbutene. Right, so we shall look at the final example. If you see, this one is a bit long. Okay, as usual, you need to find the longest carbon chain. For example, I can start from here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then you have 8 here, right? You have the vertical chain, carbon chain, you have 8. You can try with the one here. If you start from 1, 2, 3, 4, you can try to find here how many carbon you have. So if you go up, it will be 6. So that is not your longest carbon chain, which means your longest carbon chain will be the one that is horizontally the main chain. Okay, so now that you have your longest carbon chain, so it will be octane, and you have the double bond, it starts at carbon number 3, which means your name will be oct3-ene. And then you need to identify the alkyl group, which is this one. So this is actually ethyl, because this is C2H5, and this ethyl is currently attached to carbon number 4. So the name will be oct3-ene. So this is from the main chain, and then you need to put the position of the ethyl at carbon number 4, which means your the name of this isomer will be 4-ethyl oct3-ene. Okay, so that's pretty much it about the isomers. So if you have any questions, please do not hesitate to ask me.